Thank you very much, and thank you very much for this warm welcome. I'm very honored to be here in this hardware track. So yeah, I'm talking about Pocket Science Lab, PS Lab, and I want to go a little bit into detail also how we actually went into large-scale production. Seems like this is something that a lot of people are interested in here as well. So yeah, okay. So Pocket Science Lab, how to use it? Basically, it's a useful like measurement tool. That's our idea. So basically, we want to have a tool where you can measure all kinds of things. It has integrated components that can be used by pins. So you have small cables that you can plug into the pins, and you can do measurements, or you can extend it with sensors. And yeah, we have different apps. We have a desktop app, Android app, and you can of course make your own app. Here are like a few examples. So there is an oscilloscope that you can use it with. There's a multimeter, logic analyzer. You can use it as a wave generator, power source, accelerometer, barometer, compass. As I said, can plug in any sensors, any I2C sensor, that's all fine. And for example, we also have lux meter and more instruments. So how does it work? So basically you have the Pocket Science Lab and you have your phone. So you connect your phone to the Pocket Science Lab. And yeah, and you get the app. So there's an app on F-Droid and of course on the Play Store. And then basically it starts to, okay, unplug, but like it starts to yeah, collect data. For example, we have this instrument here, which is an oscilloscope. So you will have like different visuals here that you can see on the oscilloscope from the lab. So you plug in small cables here. But actually, if you just want to try out the app, and you guys know that the phone already has a lot of sensors as well, you can use it directly as well. For example, you can plug in here or switch on. You switch on the microphone and you, ooh, yeah. I don't know if you can see it on cam, but like you can try it out. So I go a little bit more in detail here later as well. Yeah, I know you guys are really into hardware, so I will hand this device around and you can like have a look onto it, and also like a box with a few more things if you're interested to do some tests right away. Okay, so basically that's how it works. Always have these questions like what are the specifics, what is the range, and so on. So here's a bit information about this. There's a 4-channel oscilloscope. We have a 12-bit voltmeter, 12-bit programmable voltage sources, and yeah, of course, logic analyzer, wave generators. Is actually also a square wave generator, not just sine wave. Capacitance, resistance. There are a lot of connectors, there's a frequency counter, and so on. So pretty cool. Then there are waveform generators, as you can see. And you can, for example, also use these plugs for robotics. Okay, so how did we actually come up with this project? In 2014, a friend of us came to the FOSDEM Summit, and like people always see this project and they associate it with FOSDEM, and they wonder like, I'm not Asian, okay? So I lived many years in Asia, and we run all these like commercial projects, what with free and open source software. For example, we set up like big offices for the Swiss Post, where we like installed 500 computers in their office with Linux, and a lot of people worked on that with GIMP and all these kind of things. So that was pretty cool, because always my dream to work with free and open source software. However, like I'm from Berlin, and I felt a bit like, you know, like when I'm in Berlin, I knew, for example, CBase and other hacker spaces, and I was like, that's how the world is. Every city has a hacker space. It turned out later when I grew up, it's not the case, yeah? So, and I went around the world, I learned languages, I'm really interested, but I feel a bit like cut off, because when I go to a hackerspace, I meet a lot of cool people, and they tell me stories, they tell me things that I don't find online yet. So we said, how can we reconnect to more cool people in the community and people who work on awesome projects? So we started this event. And we thought, well, FOSS, right? Free and open source, so we don't want to exclude everyone. We are for free, we are for open, and all these things. And where are we? We're in Asia. So FOSS Asia was the conference that we started. People come together, have ideas, and this is one idea that was started 2014. And a few years later, we find ourselves producing hardware on a larger scale. So that's basically the background. And here you see Praveen. Praveen is a physics teacher in India. And he said, we need a small instrument like to do experiments in school. So we said, yeah, cool. A lot of people have ideas. He already has like some like basic stuff. So we definitely support him. So that's how we started. And the thing was then, he also came up with the hardware. So this hardware was developed with KiCad in 2014, but it wasn't open source right away. It wasn't open. And I always said, like, I want things open, but right, we can't force anyone. So we focused with FOSAsia on our part on the software. But we kept the conversation, right? As we just heard with Wayne, right? Like, years ago, people wondered, like, how can we actually earn income, and how can open hardware work the same way that open source works, and all the same questions are coming up over and over again. And of course, a lot of developers also have this question, and we need to go step by step. So we said, let's see how this project develops. So the first version then, or the next version came up, and we were able over time to convince the hardware developer to open sources. Of course, we also paid for it, so that was part of the of convincing him, and that we collected some funds, and we were able actually to then work on GitHub, for example, put all the code there, and it was a good decision, because my thing was this: I said, like, I find a lot of projects exciting, and I can always like support a lot of developers, and I'm really into it. But like, if it's not open, right? I mean, there's so much cool stuff that's unfortunately not open, right? I want it to be open. Otherwise, there's no point for me to really engage. And the other point is that if people move on with a small hardware project, how can we stay engaged with them? Or how can we keep up the project? Yeah, so the project might die if it's closed source and we are not able to continue. So good decision, because actually 1.5 years later, the developer did move on, but in the meantime, we already got new people on board. And for example, we found guys here at the Chaos Communication Congress. We found people who give us feedback. Here's a photo, like it's very dark at the Congress, right? I mean, who has been at the CCC? Right? Yeah, I know a few people by sight, yes. So you guys know it's very dark, but like they're very cool people, like for example, Bunny Huang and others who gave us also feedback about production. So yeah, we could move on with this feedback to the next version, which is then the next version of using the form factor of Arduino Mega. Because at that time, our idea was also, if people have boxes, maybe they could reuse those boxes for our hardware, even if it's completely made from scratch. And it was also the idea here that we optimize for production. For example, originally we had components on both sides. But then, like, based on the feedback that people gave us, we optimized for production, for example, keep it on one side, so you have one run less. Yeah, keep the components on one side. So, and also like move components here and there. So there was a lot of good feedback, just like by meeting people at events like this one here today. And yeah, so we continued. For example, one of the other feedbacks then with the next version was that, yeah, we should have Bluetooth, or we should also have an Wi-Fi chip, an ESP, for example, on it. And yeah, so we added that. And we added also, like on the back, for example, you see on the device a lot of description. So we really try to think it through and make it like easier for people to work with it. And yeah, adding more digital pins, things like that. By the way, on the device itself, you don't see a Bluetooth chip and an ESP chip. We are still not like producing hundreds of thousands. We are like having batches of thousands and 5,000s that we're producing currently. The reason is like that, for example, if you export it to Japan or other countries, it's sometimes difficult. You might be successful one time, but maybe the next time it will get blocked at the border and they will say you are not certified for Wi-Fi, which doesn't really make sense to me, because the chip is certified. The hardware doesn't really need to be certified because we don't have a battery or something on it. So why can't you just put both together? But like, these problems exist, and a lot of yeah, salespeople like ask us not to do that at the moment. Okay, so so this is the current status that you also see on the device that's going around. And what are our ideas next? For example, one idea is people like to walk around with badges. And yeah, we had that at the Congress, that a lot of people had badges from different projects. So we are thinking like maybe we could like plug in a badge, for example, where people could display something. And that would be cool. By the way, this is also a FOSAsia project here, the badge magic thing that you can find on our thing. So that's an idea. And yeah, and we're working on new ideas together, for example, with partners. So this is one partner that advised us. It's the Fraunhofer Institute, IZM. They have a startup factory in Berlin, and yeah, it was really good to get this like professional feedback nowadays as well. And then, of course, we have a partner in China, so which is producing with us, and they're also looking over the hardware. And actually, we have a person who speaks Chinese. So as we have FOSAsia, like people speak all kinds of languages. So actually, like we have our contact, Mr. Witat, who goes to China and then works with the manufacturer. Because actually, maybe we started the first larger batches in like 2017, 2018. And the thing was like, maybe we could have started even earlier, but right? I mean, like you produce large batches, it's a lot of money. You need to come up with this money. And if there's an error or mistake, then that's a big thing. And so we don't have an investor, we're completely self-funded. And yeah, it was really important to work together with a hardware manufacturer and really understand how to do this. So a few lessons learned, for example, here. So we create the BOM also automatically with KiCad. That's a really great feature. And yeah, you need to work and coordinate here with producers, because sometimes some components might be older. They're not always, they may be here available, but they might not be available anymore in China. And there are already newer components that are cheaper. For example, that's a learning. Then a thing that we didn't know, actually they can, for example, produce like in reels, or they can have tubes, or like different ways to put components into the machines, and the cost is different. Yeah, so we weren't aware of that. And like as we are producing in China, I think like I'm not sure, my impression is the cost advantage is yeah, maybe getting less. I don't know, there are different opinions on this. But like as we're still producing in China, it's good to have somebody who speaks Chinese, because when I ask in English, they say yes, and he asks in Chinese, they say no. Yeah, so it's really that thing, because it's really to the point if you have somebody who can speak Chinese. And also expect components to be unavailable. So people might say, okay, maybe in 2 months the component will be unavailable, and if you have a campaign, for example, a Kickstarter campaign, yeah, and you have your timelines, so that is yeah, that could be a problem, right? And yeah, understand what they mean when they say remanufactured. I always like have challenges, and sometimes they slightly mean different things when they say remanufactured. Yeah, it could be that they have actually reels and they have production, and some components drop on the floor, and they pick them up and put them back in the reel, and then they say remanufactured. Or they have a big like batch of like you know, unused stuff, and like somebody really picks it out by hand, manually. Yeah, so it's really something of lower quality. And yeah, one thing that we had an issue with was the USB headers, for example. They didn't fit into the holes, because actually they were different USB headers, and they had different ranges what is acceptable. So we had somebody to yeah, that we needed to do this manually, push a bit. Yeah, so on every single device, that increases costs of production. So don't forget that things like that could happen. And yeah, so female pin headers weren't soldered straight, for example. So these headers that you see like sticking out there, not straight. So we needed to make another piece or kind of another small like component to make it straight during production. Also increased the price again. Yeah. So and a challenge was then that we used another flashing device for the firmware than they. And yeah, of course, we all wanted to be standard compliant. We want open standards everywhere, but it's not the case yet. So the thing is that we had some issues because we used different devices, and yeah, we solved that and we found out about that. Also, of course, expect parts to be faulty. So, for example, here you see that in the reel, it was kind of an advantage because we had two companies here, and these two companies, yeah, looked at each other. Yeah. So, is this right or is this wrong? Okay. So there are a lot of lessons learned. I'm going to share these slides. You can definitely look more into detail. And yeah, we're working on the next version. Next version is we're adding an SD card. We add a small battery to keep the time, so you can use it as a like as a hardware. For example, like elsewhere, you don't need to have it plugged into the phone or into the desktop always. Just use a battery, get the signals through Wi-Fi, or pick it up from time to time. And we are miniaturizing components. So some components, actually, when they get smaller, they get cheaper. Yeah. So this is something we are looking into this. And yeah, please talk to me if you have any ideas from your side. So, for example, what do you want to see? We are thinking about GPS. We're thinking about a SIM card module. Maybe integrating some sensors, mounts for screens, so you can have a screen or LED badge on top. Yeah, so these are ideas, and I can talk to you more also, for example, at our stand tomorrow here at FOSDEM about the architecture, about our roadmap. There's a lot of things to talk about the oscilloscope, a lot of things, and yeah, and of course we're also working on this commercially. So maybe I will be able to answer questions, and I will leave this slide. Hang on, this slide open. This slide open. How to make open hardware economically sustainable? Because that's a big goal of mine. I really want that we have more open hardware projects, not just as hacking projects, but as bringing this open hardware community to the mainstream and making more companies successful. So I'm happy to talk about our experience. So we have a break even in regards to the production costs and the running costs. Of course, the question is always, what do you calculate out as cost? Yeah, but we are good here, and we are producing more, and so happy to collaborate with anyone. Also, like we have some contract work. So if anyone here in the room is interested to work with us on a contract, please talk to us. And I would also like to call out Daniel. Daniel, hi. So we are working together on the OpenNext project with the EU-funded project. So this is also something that we could maybe recommend to you. If you have a company here in Europe and you're interested, we would like to share with you how we get into EU projects. So it's really about growing the ecosystem and yeah, using tools that are completely free, from hardware to software to the production tools. So thank you very much.
Time for a couple questions.
What was the end-to-end timeline of one version of this?
What is the end?
End-to-end timeline, like from the idea of we want to do this with it to the moment when it's commercially available.
Yeah. Yeah, what is the end-to-end timeline from the idea to like really having it? So I think like 4 years, you could say that, yeah. Whereas like there was already some proprietary hardware before, so I can't say exactly. And we basically just said like, let's see what the people come up with. Well, if somebody comes to us and says, oh, we have a great idea, we're not going to stop them, right? So so we really got like, it was after maybe 2 years that we really got serious about it. Yeah, and nowadays we know how to do it. So we actually have other projects like the Batch Magic or Neurolab, and that we can do much faster. Yeah, because we already like know how to produce, and we are happy to share this yeah, information with you. So maybe it could be faster.
Is your app up on GitHub somewhere?
Yes, everything is on GitHub, just like GitHub for Asia, or go to PS Lab website. There's also everything linked.
And what license is it under?
I think like there are different licenses, but like GPL, usually most of it is usually GPL or LGPL.
Okay.
Yeah. So it's all open.
Can we buy one today?
Yes, you can buy one. So actually we have a stand tomorrow, and there's Hong is also in the canteen, in the old canteen, you know, where everyone passes through. There's a small table with a FOSDEM tablecloth, so people can identify. It's red, and it's 60 euros. Yeah.
Maybe one more question.
basically, like we had some connections already. Sorry. So why do we produce in China and not in Germany? So as far as I know, like most producers who offer these services also produce in Germany, produce in China. So as we already have a lot of people who speak Chinese, we actually don't need to go through the producers. You know, we don't need this kind of support. We can just deal with people directly. And but there are services that are doing a great job, and I would definitely recommend this. And I think an opportunity for open hardware is local production. So right, we ship the design around the world and not the device. I think that would be my goal. But right now, this is still a very small project, and we are not at this large-scale production.
Okay, thank you, Mario.
Thank you.